Hello everyone, welcome to another kinetic tutoring video. Today we're looking at circular motion and forces, so let's just get straight into the problem. The prompt reads, a car of mass m can make a turn of radius r while traveling at a velocity v. The coefficient of friction is mu. If the mass and velocity of the car are both doubled, what is the value of mu prime if the car is still to navigate a turn of radius r? So let's take a look at the forces acting on our car in both the x direction here and the y direction here. We know that obviously there's going to be gravity applied to the car going straight down. It's going to be equal to mg. The force is going to be mg, and we know that we are going to have a normal force exerted on the car upwards by the ground. And we know that our only force in the x direction is going to be our centripetal force, which is going to be caused by friction. The friction is going to prevent the car from sliding off the road and making sure it stays on the track. So let's set up our two net force equations. We have net y and we have net x. We know that since the car isn't going into the ground or floating up into the sky, your net acceleration or your net force in the y is equal to 0. We're going to write our two forces. We have the normal force acting upwards, so we're going to make our normal force positive. Gravitational force going downwards, negative. From here we can see that 0 is equal to n minus mg. So our n and mg are going to be equal to each other, and all I did was move the mg onto the other side. And let's move on to our net x. We know that when we're talking about circular force, the equation for circular force is just simply mv squared over r. When we're talking about straight translational force, that's just going to be ma. When we're talking about rotational force, we're going to have our equation mv squared over r. And when we take a look, our only rotational force, centripetal force, we can see it's moving towards the centroid. It's going to be friction. So we'll get here that friction is mv squared over r. But we know that another way we can write this is by rewriting friction. We know that friction is simply mu, its coefficient of friction mu times the normal force that the ground puts onto the car, and we know that our normal force is simply mg. So mu times normal force will give you mu mg, and that will be equal to mv squared over r. From here we see that we have a mass on both sides that we can cancel out, so let's just do that really quickly. We will be left with mu g is equal to v squared over r, meaning that our mu is v squared over rg. All I did here was divide both sides by gravity. And now let's take a look at the second part of the problem. It's asking if the mass and velocity of the car are both doubled, what is the value of u prime if the car is still to navigate a turn of radius r? As we can see, there's no mass left in our final equation, so we'll see that no matter what the mass is, that does not affect our mu coefficient. However, we're going to have to double our velocity, meaning that where we have a v, we're going to have to replace it with 2v to get our mu prime. So our mu prime is going to be in parentheses 2v to the power of 2 over rg. Our final step is to just distribute the square, and we'll get that mu prime is equal to 4v squared over rg. And as you can see, when the velocity is doubled, the mu coefficient of friction required to keep the car on track is quadrupled. I hope this helped, and make sure to tune in later for more physics tutorials.